Hello, dear colleagues. We welcome all those interested in sturgeon breeding and rearing to the fourth part of the web intensive, preparing for and conducting a spawning campaign, which will be devoted to assessing the readiness of females to spawn using the oocyte polarization coefficient method. The method of estimating the degree of female maturity by the value of the oocyte polarization coefficient is based on the peculiarities of the structure of mature sturgeon oocytes. By the position of one of the elements of the oocyte, called the germinal vesicle, one can judge at what stage of completion of the fourth stage of maturity the female is. This is not only readiness for spawning, but also the sufficiency of fattening or wintering, the choice of transfer to the spawning mode, and so on. This method has been used for quite a long time, and one of its developers is the famous sturgeon scientist, Sergei Pajishka. The method has both strengths and some disadvantages, the description of which you can see at the bottom of the screen. However, due to its simplicity, it can be mastered and used by any fish farmer since it does not require complicated equipment, special skills, and other. To assess the degree of polarization of the oocytes, a biopsy sample with eggs is taken from the gonad with a special probe. Then, after special processing, the eggs are cut open and examined with a magnifying glass or microscopic technique. The probe has a fairly simple device and its drawings are common in many publications. Traditionally it is made of stainless steel. The screen shows the biopsy probe on a larger scale. The key elements of the stylus design are the pointed end and the groove for picking out the eggs. Traditionally, to work with different species of sturgeon, different size probes are used, which differ in length and diameter. On the photo presented on the slide we see several variants. The smallest is for sterlet, medium for Russian and Siberian sturgeon and their hybrids, as well as starred sturgeon and other medium-sized species. The largest is for females weighing more than 30 to 40 kilograms, such as beluga, kaluga, Amur sturgeon, and similar species. If there is no possibility to make a set of probes, it is possible to use the average probe, the dimensions of which are given on the screen, as a universal one. Well, and in the most extreme case, if there is no probe, and it is necessary to determine the polarization coefficient urgently, the probe can be promptly made from an ordinary screwdriver, as shown in the bottom right photo. Before discussing directly the sampling technique and determination of the OPC, we will briefly review some key features of the structure of the maturing oocyte. An oocyte has a rather complex structure, but it is not all elements that are important for us, but those that are fundamental for determining the polarization coefficient. These are the sheaths, the poles, and the germinal vesicle. So, the oocyte sheaths. An oocyte that has not ovulated has several sheaths. The outermost one is not the shell of the oocyte itself and is an outgrowth of the follicular epithelium, in which, as in a pouch, there is an oocyte. At ovulation, the follicular sheath dissolves, but when we take a biopsy sample, it is still present. And also the oocyte has 3 of its own sheaths, a gelatinous sheath and 2 yolk sheaths. This multilayeredness is usually visible on the oocyte cross-sections after fixation. Under the membranes is a layer of pigment granules. It is this layer that actually provides the caviar coloring. The second important aspect is the polarity of the oocyte. An oocyte of the fourth stage of maturity is a large cell that has a distinct polar structure. Traditionally, the oocyte is distinguished between the animal and vegetative poles. The vegetative pole of the oocyte, also called the region of the coarse yolk, is filled with grains of yolk of a larger fraction and drops of fat, which makes it visually more coarse-grained. Animal pole, area of fine-grained yolk, contains the bulk of cytoplasm, small yolk grains and lipid inclusions. On a cross-section of the fixed oocyte, this area is visualized as denser and a bit like plasticine. In the left photo, we collected eggs with different coloration of the animal pole. The animal pole is clearly distinguishable visually. In this area, 1 or more rings are visible on the surface of the oocyte. Their pigmentation differs from the coloration of the rest of the egg. As a rule, the animal pole is much lighter than the rest of the oocyte, but in some species, such as the Russian sturgeon, the accumulation of pigment in the animal area causes this part to become darker. In this picture, we can see different variants in which the animal pole of the oocyte is expressed to a greater or lesser degree. At the same time, there is a characteristic distinguishing feature. The animal area always occupies a smaller area compared to the rest of the evenly colored area. Understanding the peculiarities of egg polarity is necessary for us to estimate the polarization coefficient, because the cut axis must necessarily pass through the center of the animal pole. And finally, the germinal vesicle. The oocyte nucleus, or otherwise known as the germinal vesicle, is located approximately in the middle of the oocyte. However, in sturgeons, even at the beginning of the fourth stage of maturity, the nucleus is not exactly in the center of the oocyte but is slightly displaced toward the animal area. On a cross-section of an oocyte fixed in one way or another, the oocyte is visualized as a large bubble of round or oval shape. At the stage of completion of the fourth stage of maturation, the germinal vesicle gradually shifts toward the animal pole and moves from a zone of coarse-grained yolk to a zone of fine-grained yolk. After hormonal stimulation, ovulation begins and the germinal vesicle comes close to the surface of the oocyte, after which its shell is destroyed and the contents of the vesicle, that is, the karyoplasm and chromosomes, pass into the cytoplasm. In this state, the oocyte is ready for fertilization. The most important thing for us in this information is that by the position of the germinal vesicle relative to the animal pole, we can judge the timing of the completion of the fourth stage of maturation, and the ability of females to respond to hormonal stimulation. And now about how to take a sample of eggs or make a biopsy. Fix the selected eggs, cut them and calculate the polarization coefficient. First of all, an important note: because we are disturbing the skin and integrity of the gonad during the biopsy procedure, all steps must be taken as carefully as possible. As indicated on the slide, there is a large blood vessel in the gonads of sturgeon, so bleeding is possible after removing the probe from the fish body, but in the vast majority of cases it is not dangerous for the fish and quickly stops when they return to the water. The biopsy procedure itself is also not harmful for the fish. However, all precautions must be observed, including disinfecting the instruments used after each fish. The biopsy sample is taken from the abdominal or lateral side of the body. Our experience shows that performing the biopsy from the abdominal side is easier and safer. The puncture site is the area near the third or fourth abdominal scuots, depending on their density on the body. If you count from the abdominal fins toward the head, a puncture is made in the peritoneum with an awl before the probe is inserted. Only a sharpened probe can be used for the puncture as well, but we think separating the operations is more correct. To avoid accidentally damaging internal organs, when puncturing, the awl, or probe, is directed parallel to the bug line with a slight deviation to the outer side of the fish torso. The probe is inserted into the puncture in a triple motion. First, to pass through the peritoneum, the probe is inserted at almost right angles to the abdomen of the fish. Then change the inclination of the probe to close to parallel to the body surface. Guide it along the body with a slight inclination towards the back, and smoothly lead the probe towards the head until the slit is completely inside the body. Then stop the forward movement, make one complete turn of the probe around its axis in order to capture the eggs, and then carefully extract it from the fish. The extracted eggs are placed in cuvettes with cavities or in tubes separately from each female, and then processed in one way or another. After taking the sample, in order to prevent infection, it is necessary to treat the puncture area with any antiseptic for external use. In the absence of special means, concentrated solution of methylene blue or 0.1 to 0.5% solution of potassium permanganate can be used as a disinfectant. When performing a biopsy, it is important to observe several mandatory conditions to prevent possible injury to internal organs. First, care should be taken to ensure that throughout the procedure, the fish is straightened along the body axis and well fixed in order to prevent possible jerks resulting in a change in the direction of the probe movement. Second, the probe should be oriented parallel to the lateral surface with a slight tilt towards the back during sampling. The slope should not be too great so that if you accidentally jerk, the probe does not hit the kidneys. In the right photo we can see that the fish is bent. This should categorically not be allowed, as the slightest mistake will cause the probe to damage the intestinal walls. If the end of the probe is sharp, a serious injury in the described case is almost inevitable. Now we'll watch a short video of what all of the above looks like in practice. First, at the tempo as it happens, the way it is done. Without slowing down and without speeding up. And now let's repeat again at a slightly slower pace. Usually the biopsy procedure takes no more than 1.5 to 2 minutes per fish, less if you have experience. Therefore, anesthesia is usually not required. At the same time, if the biopsy is carried out for the first time or the work with large fish, more than 20 kilograms, is supposed, you can use anesthetics such as clove oil, benzocaine, lidocaine, and others. The processing of extracted eggs is performed separately from each female. 3 steps can be distinguished in this process: fixation, cutting, and measuring the polarization coefficient. There are thermal and chemical methods of oocyte fixation. With the thermal method, the eggs are boiled in water or steamed, depending on the possibilities and the number of fish. We usually use this method for fixing eggs as the easiest and fastest. If you don't have test tubes or a burner, you can use an ordinary spoon and an electric stove for cooking. If you use a steamer, you can use containers for freezing ice with small cells to place the eggs in it. This is how to cook eggs from one female in a test tube. Remember to keep the tube at an angle so the liquid does not splash out, and slightly above the torch burner, so as not to overheat the glass. For chemical fixation, cereal liquid, or, in its absence, 9 to 10% formalin is used. The main disadvantage, as mentioned above, is a very long fixation time. For example, when using formalin as a fixative, the duration is at least 12 hours. Another disadvantage is the use of toxic chemicals. For example, cereal liquid contains glacial acetic acid, a very dangerous volatile compound. Replacement of glacial acid with less concentrated acetic essence is possible, but leads to the fact that the exposure time increases to 6 to 9 hours. The second processing step is the cutting of the oocytes that have been fixed in one way or another. When cutting, the oocyte is held either with the fingers or with forceps. If cutting is done using a microscopic technique, ultra-thin microsurgical or ophthalmic forceps can be used to hold it, but regular, small forceps are also possible. The egg is positioned so that the animal pole is clearly visible and is cut in 2 halves through its center with a blade or narrow eye scalpel. In the photos, we see that the egg is positioned with the animal pole upward. Next, a blade is placed to its apex, and strictly in the middle the egg is cut. The final step is to calculate the polarization coefficient. To do this, use the scheme to the right to make measurements and then using the formula to calculate the value of the coefficient. Let's discuss this in more detail. 2 indices are used for the calculation. The first is the distance from the inner surface of the sheath at the location of the animal pole to the upper surface of the germinal vesicle, denoted in the diagram as L small and highlighted in red. Then measure the size of the oocyte in the direction from the animal to the vegetative pole along the outer surface of the oocyte sheath, marked as L large. A very important nuance of measurements is that in the first case, the sheath is not measured, and in the second, measurements are made exactly on the outer edges of the sheath. Then we return to our formula and calculate the value of the coefficient by simply dividing the values of L small by L large. Usually the value of the polarization coefficient is expressed in fractions of a unit to the nearest hundredth. However, some people find it more convenient to use percentages. To do this, it is sufficient to multiply the result by 100. Let's see how it looks on the real eggs under a stereo microscope. This is a winter fish, from which it was planned out of season receipt of eggs and, accordingly, evaluated the sufficiency of wintering. As we can see, not quite enough yet. A characteristic sign of this is the germinal vesicle is almost completely located in the area of coarse-grained yolk. In this slide we see an egg from a female already almost ready to spawn. It is clearly visible that the embryonic vesicle has already completely moved into the area of the fine-grained yolk. At the same time, such fish, of course, still need a little pre-spawning holding. And 2 more examples. On the left picture is an oocyte from a female ready for hormonal stimulation. Optimal values for hormonal stimulation and spawning are OPC from 0,07 to 0,04, on average about 0,05. In the right photo, we can see that the germinal vesicle has come close to the sheath. This is an over-matured female that has been kept at spawning temperatures unnecessarily long. There is still a small chance to get eggs from such a female after the hormonal injection, but the eggs will only be suitable for food purposes and it will not be possible to fertilize her. What should you do if you are unable to take accurate measurements? There are several ways of visually assessing the degree of polarization that provide a relatively accurate assessment of the readiness of females to spawn. As we can see on the screen, they are all based on a comparative assessment of the proximity of the germinal vesicle to the animal pole. The first variant is based on the principle that the value of L small is approximately equal to half the diameter of the germinal vesicle. The second variant is when the germinal vesicle is in the middle of the area of the fine-grained yolk. And the third is when the germinal vesicle is in the upper quarter of the oocyte. In spite of the sufficient correctness of such methods, it is not advisable to start working in this way at once. One should first to get our own database so that we can determine this parameter by eye if necessary. In order for you to check yourself if you have understood everything correctly, we propose to take a little test and determine the polarization coefficient of the schematic oocyte, which is presented now on the screen. We purposely used the schematic image to make it easier for you to identify the measurement points, and we got matching results. For those who are a little confused, I will now give a little hint in the form of markup lines. I think that once the markup lines appear, no one will have any problems calculating the coefficient. So, we reveal the results, and you compare them to your own. If the numbers are the same, then you've done very well on the test. To make the necessary measurements, you can use a classic stereo microscope equipped with an ocular micrometer with a measuring ruler, and more affordable technical solutions. For example, compact USB microscopes, the cost of which starts from $10. In this case, to measure distances it is necessary to use some image processing program. We use the program ImageJ, but since a completely simple action is required, any other program will do. How to interpret the results obtained when determining the polarization coefficient. The table on the screen shows the possible ranges of OPC values after keeping the females in pre-spawning water temperatures for a period allowing to accumulate a minimum heat reserve. OPC of 0.03 or less is overmature and close to overmature. If the OPC is a little more than 0.03, then there is still a chance of getting eggs, at least for food purposes. OPC in the range from 0,07 to 0,04, the best degree of readiness for spawning. It makes sense to immediately conduct hormonal stimulation. OPC values greater than 0,08, females require additional pre-spawning holding, duration of which, depending on OPC values, varies within the interval from approximately 5 to 15 days. When the coefficient exceeds 0.18, it is practically impossible to spawn, and such females need either additional wintering or one more feeding period. Pay attention that we are talking about OPC values at the moment when females have already spent some time at pre-spawning temperatures and accumulated minimal necessary heat reserve. Why this is important we will tell you in the next lesson. The oocyte polarization coefficient can be used not only to evaluate the readiness of females for spawning, but also at other important stages of the fish breeding process. It can be used to evaluate the sufficiency and efficiency of the fattening period, wintering, and to control the process of transferring to the spawning mode. Features of the method application at each stage are described in detail in the relevant parts of our web intensive. And that concludes our session today. Thank you for your attention. We thank everyone for their participation and welcome them to our other online events.